Okay, so the last problem that I'm going to do is page 299, question 48. There was another problem on the list that I gave, but the second last problem that I wanted to do is very similar to one of the problems that I just did, so I don't want to waste time doing a same kind of problem again. This problem is a little bit different in its approach. It's still with the normal distribution, but it requires you to use the standard normal, and you will see why. Okay. So as I go through the problem, I'll try and point out to you how we identified that we need to use the standard normal distribution. Okay, so what is the information that's given to us? It says that a machine fills containers with a particular product. This could be a machine that fills soda bottles with soda, or it fills potato chips bags with potato chips, etc. It says that the standard deviation of filling weight, so the machine is not perfect. Okay, the machine is not perfect, meaning that sometimes it fills a little bit less, sometimes it fills a little bit more, and so x is equal to the filling weight, the weight filled. So since the machine is not perfect, ideally it would be nice if the machine filled exactly the same weight in every bag or every bottle, but that never happens. So x it varies a little bit randomly, and we are told that it's normally distributed, and the numbers that are given to us is that the standard deviation is known to be 0.6 ounce. Okay, that's what the first line tells us. Okay, is known from past data to be 0.6 ounce. And then it says 2% of the containers hold less than 18 ounces. So notice the mu is not given, the mean is not told to us. We are told that the standard deviation is 0.6 ounces, and we are told that 2% of the containers hold less than 18 ounces. Okay, so this is the information that's given to us, and the question says what is the mean of this distribution. So if the information given to us is that we have this machine, it fills things by certain weight, and it's not perfect, the standard deviation of the weight that it fills is 0.6 ounce, and 2% of the bottles or the packets have 18 ounces or less. So what I've done is I've taken the narrative and I've just drawn it, put it on the normal distribution picture. All right, and we are being told to find this location. All right, so if we use the rule that we have described in class, that is, I know a probability, I'm given 2%, right? So I've been given a probability and I want to find a location on the x-axis. So the location that I want to find is this middle where I have just drawn this dot, the mean. That's the location I want to find. So the rule says that if you know a probability and you want to find a location on the x-axis, you would use norm inverse. Okay, so now let's see what happens if we try to use norm inverse. The norm inverse requires 3 inputs. If you look at the Excel function, okay, this one needs, the first input is a probability. I know that's been given to me, 2%. The third piece that you need to input is the standard deviation, that has also been given to me as 0.6 ounce. But the second parameter, the mean that you need to input, has not been given. Okay, so if you apply the rule, that the guideline that we had mentioned, and try to do it directly, we immediately get stuck. Okay, but that doesn't mean the rule is invalid. If I know a probability and I want to find a location on the x-axis, I have to use inverse. There's no way around that. But instead of using the norm inverse, I will use norm S inverse. Okay, Why am I using norm S inverse? Because remember, for the norm S inverse, a standard normal distribution, I know the mean and I know the standard deviation. The mean is 0 and the standard deviation is 1. Okay, so here's the reasoning. I'll take the standard normal distribution, its mean is 0 and its standard deviation is 1. And I will still get, look at this 2%. And I will find what is the location on the x-axis that corresponds to a tail of 2%. Okay, so in order to do that, in order to find A, I will still use inverse, but I will use norm S inverse. So this is equal to norm S inverse of 0.02. Okay, so let's see how much that is. We'll do the calculation. Equal to norm S inverse of 0.02. Okay, so this is minus 2.05. So what does that mean? That means A is 2.05 standard deviations below 0. That means, what can I conclude? I know that 18 ounce is 2.05 standard deviations below this mean. I'm trying to find this mean. So the calculation that I just did tells me that 18 ounces, this is given to me in the problem, is 2.5 standard deviations below the mean. So now not 2.5, I'm sorry, 2.05. So let's say 2.05 standard deviations. How do we get 18 ounces? How do we standardize 18 ounces? 2.05 standard deviations below the mean is minus 2.05 is 18 ounces minus the mean, which we want to find, divided by standard by sigma. So this is how we standardize values. So 18 ounces is 2.05 standard deviations below the mean, which means minus 2.05 is equal to 18 minus mu divided by 0.6. Therefore, mu is equal to, if you just move things around a little bit, 18 plus 2.05 times 0.6 is equal to, let's see what this turns out to be. Is equal to 18 plus 2.05 times 0.6 is equal to 19.23. So the mean is 19.23 ounces. So notice that in this problem, the logic was no different. That is, if you know a probability and you want to find a location on the x-axis, you have to use an inverse. It's just that you have to use the standard normal instead of norm inverse. Okay, all right, so this was the last problem that we had for the collaborate